Hello everyone, so my name is Pankaj Singh from Sri Ram's IS. Today before you with a topic on your history optional paper 1. Paper 1 is what I'm gonna be talking about, and section A, which is ancient Indian history. So I'm having 10 years plus experience both in offline online mode, MA in history and also LLB and LLM. So moving with the topic is mathematics in ancient Indian history. So that is what we are going to be talking about. You can expect a question on this attached to some other question, or maybe a full-fledged question, maybe a 15 marker also in your mains examination. All right, so if you see, the knowledge of mathematics first of all can be reflected as early as Indus Valley civilization, because you see we have seen some sort of planning with respect to towns, and that reflects that these people had knowledge of mathematics. The cities cutting each other, the streets in the cities cutting each other at right angles, right? So that ways even the Vedic people, the Vedic literature, the knowledge contained in Vedic literature also affected the growth of mathematics in India. That is what you have to understand. So further, if you see the sacrificial altars that we had in the Vedic life also indicate the knowledge of geometry possessed by the Vedic age people. For example, you see, they definitely had knowledge related to squares, rectangles, circle, triangles, etc. So over a period of time, by the time of growth of Mahajanpadas also, we see, as that period approached, by 5th and the 4th centuries BC, we saw that technical arts went on to achieve that level of excellence, and that was reflected in the growth of urban centers, towns and cities. So further, if you see these towns and cities which had become the order of the day by second urbanization, right? By the time of second urbanization, they had become the order of the day. These towns and cities having been made requires what? Planning. And as I have just told you with respect to Indus Valley civilization, this planning definitely reflects good knowledge of mathematics. So these towns and cities which have emerged by the time of second urbanization were built on the basis of geometry, right? And a lot of inspiration were coming from the Dharma Shastras. The Dharma Shastras, this is what you have to remember. Are we getting the point? Now, moving further, these towns and cities which had emerged around this point of time exhibit and indicate very strongly in the direction of expertise and specialization which was achieved by ancient Indians in the field of civil engineering by this time period. So we must be very proud of the fact that as early as 5th or 6th centuries, 4th to 5th centuries BC, we had commendable knowledge of civil engineering available with us, and all thanks to the knowledge of mathematics that these ancient Indians were able to develop upon. Numerous historians and scholars agree to the fact that the level of mathematics, the degree of mathematical knowledge which Indians had achieved by the time of Gupta time period, you see, it was much ahead. It was far ahead when compared with the rest of the world. So by the time of the Gupta period, the degree of knowledge that was attained by we as Indians, you see, had gone on to become unmatched and unparalleled at the world's level. Nobody in the world's level at that point of time, by the time of Guptas, could claim to have had that degree of mathematical knowledge which Indians had come to possess. And you see, we are not talking about it merely for the sake of saying it or out of some fancy or something. There is a lot of evidence which indicate that we definitely possessed this degree of knowledge. So we have this Bakshali manuscript. So it is written on the leaf on the birch. So when you would have studied sources to study history, they would have talked about manuscripts. So this Bakshali manuscript, basically, where has it been excavated? One of the villages in Peshawar, basically. Some of the fragments had decayed. It is available to us in fragments. Now, this manuscript has given us a great deal of, you know, idea about the state of mathematics in ancient Indian history, right? So, what was the degree, to what extent, what we have achieved in this domain of mathematics? This manuscript speaks volumes about it, volumes about it. Now, there's a lot of controversy related to the time period that this manuscript might have been written, right? However, what we have got today is only fragment of this manuscript. Major part of it has been lost. Now, what I was telling you, that it is ascribed to 280 on the basis of carbon dating. Now, there are some fragments of it which are dated later, so there is not much agreement with respect to date. However, we have this gentleman K calling it to be a work of 12th century AD, but the kind of language is that is exhibited in this manuscript, the mixed Sanskrit and the Prakrit dialect, basically that indicates, you see, that the opinion of K cannot be accepted, the time period that he ascribes this manuscript to be belonging to. Now, talking about this manuscript, actually manuscript further, let us try to see, and trust me, you're going to be feeling too proud of being an Indian now. This manuscript deals not only with elementary topics like fractions, like square roots, like arithmetical, and geometrical progression, but it deals with a spectrum of subjects. For example, this manuscript deals with some advanced topics, and trust me, if you personally ask me, I had been absolutely a backbencher and an underperformer, rather a non-performer with mathematics. When I studied this topic for the first time, this is when I realized, oh my God, there can be such spectrum of topics in mathematics. So this Bakshali manuscript deals with some advanced topic of mathematics like summation of complex series, simultaneous linear equations, and indeterminate equations of the second degree. Now, don't ask me what is indeterminate equation, either of the first or the third degree. Yeah, I am not the right person to teach you mathematics. I can teach about mathematics for your history. So this Bakshali manuscript shows that some of the work was done on the theory of numbers in the direction of what? Extracting the square root of a non-square number. Extracting the square root of a non-square number. Are we getting the point? So this is what we have to remember. This Bakshali in the manuscript is very, very important. Now let us talk about a very great gentleman, which is Aryabhat, and his work Aryabhatiya. Sometimes it is also mentioned as Aryabhatiam as well. So it is one and the same thing. That is what you have to remember. So Aryabhatta's Aryabhatiya is what we are going to be discussing. So Aryabhatta was born somewhere around 476 AD. I'm sure majority of you know this, and probably he was born at Kusumpura or Patliputra. And Aryabhatta has been widely accepted and regarded as the first Hindu algebraist. Now you can recall, that sine, cos, theta, tan theta and all, that is all algebra. I can very well recall when I was for the first time introduced to algebra. I used to hear that it's very interesting, but for me, really, it gave me one of the worst experience of my life. Anyhow, so Aryabhatta was the first gentleman to treat mathematics as a distinct subject. Now, this is very, very important. It was Aryabhatta who started treating mathematics as a distinct subject, something which has not happened so far. We have 33 shlokas of his mathematical works, and these shlokas form a section of the astronomical writing as well. So this is believed to have been composed somewhere around 499 AD, when hardly he was of the age of 23 years. Now this is very, very interesting. In the age of 23 he had composed Aryabhatiya, right? Very interesting, isn't it? So the mathematical knowledge of Aryabhatta goes on to deal with several topics like the squares and the cube roots. Then it also deals with the rules of involution as well as evolutions. Mind it, rule of involution and evolution. Aryabhatta deals with arithmetic progressions, both of the numbers as well as of their squares and cubes. Now this is something great. It deals with not only arithmetic progression but both of numbers as well as their squares and cubes. That is very, very amazing. Are we getting the point? In the time of no computers, this was definitely a remarkable achievement. With respect to the sphere of geometry, so in the realm of geometry, Aryabhatiya dealt with geometry and several of its properties like that of circle. It also goes on to discuss what questions related to projective geometry, has been dealt with in Aryabhatta's Aryabhatiya. Are we getting the point? Now, geometry here has also gone on to give a value for pi. Now, that's very, very amazing. Aryabhatta has gone on to give us the value of pi, namely, 3.1416 or 3-177 upon 1250, which is actually far more accurate than any suggested value which was available at that point of time. So this is what you have to remember. A very accurate value, far accurate value than any of the values available. Now, over a period of time, this was further improvised upon by later Indian mathematicians up to 9 places of decimals. So, over a period of times, Indians had worked and contributed further with respect to value of pi. Further, you see Aryabhatta's Aryabhatiya talks about algebra, things related to simultaneous equations with 4 unknown quantities as well. So when it comes to algebra in Aryabhatiya, simultaneous equations with 4 unknown quantities have also been solved in it. Also, the problem of finding a general solution of the indeterminates of the first degree is successfully tackled here in Aryabhatiya. Are we getting the point? So before I move on, I want to give you some information related to our GS Foundation batch, exclusively in English medium, for UPSC 2024. So we have great deal of experts available with us, and the batch is beginning soon on 22nd of this month. So do hurry up and enroll yourself for UPSC 2024 GS Foundation batch for civil services examination. Are we getting the point? Now we've also started already geography optional batch since 16th of June. It's just been 3 days, and the mentor is Priyesh Singh Sengar sir, and you can use Sri Ram's code to get yourself subscribed in the course. Then we also have very soon, by 10th of the next month, 10th of July, anthropology, and it would be taught by Thiru sir and Kavita ma'am. So again, you can refer your friends just in case they're looking for wonderful educators. Now coming back to our topic that we were discussing on mathematics in ancient India, wherein we were talking about what all information has Aryabhatta provided to us in his work Aryabhatiya. You see, trigonometry, right? Trigonometry was also being cultivated around this point of time of Aryabhatta, and this is also evident from the use of sine functions, which was made for solving the problems of astronomy, the questions of astronomy. One of the most important, one of the very significant feature of the work of Aryabhata's mathematical system has been his unique system of notation. Now that's very, very significant. One of the very significant aspect of the mathematical system given by Aryabhata has been that of the system of notation, Are we getting the point? Now you see, the system of notation of Aryabhata is based on decimal place value system. What is it based on? Decimal place value system, which has been unknown to other ancient people, which has been completely unknown to other ancient people. We cannot say with definiteness whether Aryabhata went on to invent the system or whether he merely improvised upon an existing one, but definitely it was a great contribution. This is what we have to remember. Now coming over to the decimal system, Arabs came to learn it from Indians, and because of the fact that Arabs had learned it from India, they started calling the decimal system as Hindi Sat. What did they call it as? Hindi Sat, that is the Indian art. So Arabs had learned the decimal system from India and they started using the term Hindi Sat, that is the Indian art. So they started calling it as an Indian art. Are we getting the point? Now, moving further, having learned the decimal system from India, these Arabs passed on the decimal system to Europe, where the old Roman numerical system came to be now replaced. So it went on to replace the old Roman numerical system. The next mathematician that I'm interested to talk about for your knowledge is Brahmagupta. Is Brahmagupta belonging to what time period? Belonging to 7th century AD. Belonging to 7th century AD. Yeah. So you see, while we have Aryabhatta who excelled as an observer with respect to classification of astronomical data, we have Brahmagupta as much stronger a mathematician, Now this in any way does not belittle Aryabhatta. Please understand this. We are just trying to say it a little, more interestingly. So Brahmagupta is very, very famous. He is remarkably known for his Brahma Siddhanta, which was composed somewhere around 628 AD. So the Brahma Siddhanta given by Brahmagupta covers very briefly what all aspect does it touch upon. So we are going to name them. So Brahma Siddhanta talks about the ordinary arithmetical operations. So Brahmagupta has given the work Brahma Siddhanta, which talks about the ordinary arithmetical operation. It also touches upon the concept of squares and cube roots, as well as the rule of three. Further, if you see, Brahma Siddhanta has gone on to elaborate upon interests, right? Interests. It has talked about progression. It also delivers knowledge related to geometry. And now when it comes to Brahma Siddhanta talking about geometry, it also included the treatment of the rational right-angled triangle. I hope as I say the right-angled triangle, this image is definitely figuring in your mind, right? Now, Brahmagupta's Brahma Siddhanta has also talked about the elements of a circle. It is usually standard 8 that we talk about some basic primary knowledge of elements of circle. Now further, it illustrates information related to elementary mensuration of solids. It also talks about shadow problems, then the negative and the positive quantities. Also, it has talked about cipher and the surds. You remember in our school time we had surds and indices chapter put together. Now Brahmagupta has also mentioned in Brahma Siddhanta right? Concept related to simple algebraic identities, right? Brahmagupta has mentioned simple algebraic identities. Also, it has gone on to elaborate, the work has gone on to elaborate indeterminate equations of the first and the second degrees, of the first and the second degrees. This reference had also come when we were talking about Aryabhatta. Now, Brahma Siddhant also talks about simple equations of the first and the second degree, and also special attention in the work has been given to cyclic quadrilaterals. Moving further, let us talk about this great astronomer and mathematician whose name is Bhaskara. Astronomer and mathematician Bhaskara. So the time period in which Bhaskara had been living was the 12th century AD, and the region that he has been associated with is Saurashtra. He has been associated with Saurashtra. One very interesting fact about Bhaskara has been that Bhaskara had been a disciple of his own father. So Bhaskara was the disciple of his own father, and the name of his father was Maheshwara. So when we talk about Maheshwara, the father of Bhaskara, Maheshwara himself was an astronomer, and that he was very learned scholar in numerous branches of science, So maybe it were the hereditary genes which were coming from the father to the son. Now I am not belittling the contribution of Bhaskara in any way, all right? So, when we talk about Bhaskara, the great astronomer and mathematician, one another important point for us to remember is that he had been a great admirer of the mathematician that we have just talked about, Brahmagupta. So, if you can recall, we have talked in details, the work of Brahmagupta, which was Brahma Siddhanta. So Bhaskara has gone on to compose one of his masterpiece, which is called as Siddhanta Shiromani, or simply Siddhanta Shiromani. Now this Siddhanta Shiromani has 4 parts, that is Leelavati, right? Now Leelavati is called so because of the name of his daughter. Then comes Bij Ganit. Now Ganit is the term for mathematics. C is Graha Ganit. And fourth one, or the D, is Goladhyay. So Leelavati, Bij Ganit, Graha Ganit, and Gola Adhyay. This is what you have to remember, the 4 parts of Siddhanta Shiromani. Now you see, Leelavati goes on to deal with arithmetic and geometry. Leelavati deals with what? Geometry and arithmetic. So geometry and arithmetic have been dealt with in Leelavati. Then Leelavati also deals with 8 mathematical operations. Very important. It deals with 8 mathematical operations like the addition, the subtraction, the multiplication, the division, the squaring, the cubing, extraction of squares and cube roots. This is what you have to remember. It also deals in inversion method. It also deals with unitary method and quadratic equation. That is what we have to remember. And what work are we referring to? We are referring to Leelavati, right, which has been named after his daughter. Are we getting the point? Further, if you see, Bhaskar was quite a well-versed personality. He was completely aware of, he had good knowledge of geometry, which is the Kshetra Ganit. Are we getting the point? Further, this great gentleman Bhaskar has also gone on to provide us numerous theorems, many theorems related to topics like calculation of the altitude. How do you go on to calculate the altitude? Also the area of triangles, right? and I think we all have learnt that at our schools, if not at school, at least for UPSC. So it has gone on to give us calculation about altitude, the calculation of area of triangles, and also calculating the area of quadrilateral, the area of quadrilateral. This is what you have to remember. Further, if you see, Bhaskara has gone on to give us quite good formulas related to calculating the area of the circle, in terms of, now this is important, in terms of chord, and also vice versa. Okay, so in terms of chord and in terms of vice versa, calculating the area of the circle in terms of chord and the other way round also. Now, Bhaskara's chapter on Bij Ganit, it deals with what? Fundamental operation. Now, that's very, very significant. Bij Ganit deals with fundamental operation with positive and negative quantities with zero, that is shunya, with symbols indeterminate simple equations of the second degree, This is what you have to remember. That's found where? That's found in Bij Ganit. Further, if you see, the work of Bhaskara had been quite prevalent and widely popular, and they have been acclaimed as the comprehensive compendium where in Indian mathematics. So works of Bhaskara have been widely acclaimed, So this is what you have to remember. Moving further, and this is going to be the last slide for the day, when we are talking about Bhaskara as an astronomer and great mathematician, right? The works of Bhaskara, which is Leelavati, and as I have told you, it has been named after his daughter, and Bij Ganit, they were quite prevalent, they were widely popular, and they were so rich in mathematics that ultimately in 1577, right, Leelavati was translated into Persian. So in 1577, Leelavati was translated into Persian, and in 1665, Bij Ganit came to be translated into Persian. Bij Ganit have been translated into Persian. So 1577 Leelavati and 1665 Bij Ganit came to be translated into Persian. And interestingly, the works of Bhaskara, Leelavati and Bij Ganit over a period of time in the modern time came to be translated also into English language, English medium. So that is all that I wanted to give you for your ancient Indian mathematics, state of mathematics in ancient India. So I hope it made a lot of sense to you, and you would be able to crack at least one question if asked in your mains examination history optional paper 1. So thank you so much for your time and patience. Have a great time. Bye bye.